this is Praminda. Praminda has many years experience around robotics and assistive technologies. And I have to say, Praminda, I didn't realise you were a professor. So it's Professor Praminda. So basically we will have the presentation for approximately 30 to 40 minutes. And then we'll have an opportunity to ask any questions. And this is a very interactive presentation, which I'm sure you'll enjoy. So I'm going to hand over to Praminda.
Thank you, Brett. So I'm going to do a screen share of my presentation. So if you just give me a moment, and I'll remember to click on the share sound this time. And everyone can see my screen. Yep. And I think I should be able to hide that. And are you all okay seeing my screen? Brett?
Yes.
Is that okay? Okay, great.
Yeah. Nice.
So, good morning, everyone. I'm pleased to have this invitation to talk to you about a really specific aspect related to why we find robots are not out there working alongside health and social care professionals. And the key reason is ensuring safety. Safety from a number of different dimensions. And I'm going to share with you today some of the robots that we have. We've got some exciting live tour of the lab that I work in here at the University of Nottingham. But I'm going to start off by giving you a quick overview of my research group here, take you through some of the robots and how we've been using them, have a review of some of the gaps in standards and assessment and methods which we're looking to address, and hopefully this will also be of interest to you. I'm always looking for collaborations to consider these aspects in real-world settings. So one of my objectives today is to see if anybody is interested in working alongside us in some of our research. So I joined the University of Nottingham towards the end of October 2021. Before that, I was at the Bristol Robotics lab, where I set up an assisted robotics research group. And here in actually, can you see the whole screen? Because the top of mine is cut off with the information about screen sharing. And
no, we can. I can see the whole screen.
Oh, okay, that's fine. It's just me that I can't see it. Okay. So within our cyber-physical health and assistive robotics research group, we are looking at various foundational areas of research. So a key one is around safety. You've got projects looking at benchmarking the performance of robots like this robot arm behind me that can be operated remotely or be taught to work autonomously. We're looking at user-centered design methods whereby we can ensure we understand requirements and needs within a lived experience context of long-term conditions, etc. We are also looking at how we ensure we're deploying these robots ethically and responsibly. They are going to impact on people's lives, how care is delivered, what expectations there are of care, and new models of care emerging. We're also looking at smart sensors and embodiments to try and bring understanding of the real world in to the robots. So you can sense what's going on, and you'll see some of the sensors that we're using later on in our tour. We also are working on how to use these robots so they can help do some practical tasks, pick up things, bring them over to you, etc. A lot of work in telepresence and teleoperation, and this is where a human is guiding the robot, and you will see Brett using one of the telepresence robots here in the lab later on a guided tour. ensuring that we can communicate with these robots and have people with a range of different physical and sensory impairments to interact intuitively with the robots. One of our research areas is looking at accessible human-robot interaction collaboration. And then we're looking at how we get these robots to move and navigate around our environment safely. And you can find out more from our research site website, where there's a link there at the bottom. So when you think of assistive robots, usually people think of stuff they've seen on television, anthropomorphic robots, so human-looking robots, like this Pepper robot, or maybe this Care robot here. However, robots come in all shapes and sizes, particularly when they're being developed to support living in the home or in hospitals. So I have used this categorization of robots which are for domestic, supporting people in the home with cleaning, delivery, security, food preparation, so domestic service robots, robots which are used for social companionship, telepresence robots where there's a person at the end, or other robots which are more zoomorphic, so look like animals, like Paro, the seal robot. You might have come across this, being used to support people with dementia who might start to get very agitated and anxious, and the whole action of stroking and cuddling something can help calm people. It's got numerous sensors integrated into it, as do these other robots, so that it is able to respond to people's interaction as they take place. And then I've got a group here, extended living applications, and these are robots that are being developed to offer various types of physical assistance to support activities of daily living. We've got ones that can do fetch and carry tasks, some more research-focused experimental ones. I don't think they've ever made it to the market, the Panasonic hair washing robot. And so this means that people can be supported in their own homes with the help of somebody else, or control the robot themselves, or the robot learns how to support the person. We're talking about this, but and it's not available yet. I should say that quite a lot of these extended living application focused robots are still at very much a research stage, because we haven't overcome the safety issue, being able to operate in all different types of circumstances in the home. A mobility category there for robots that are supporting, and you'll have a look at the Leo Walker and see how the data from this Leo Walker can be used in a bit when we go on a tour of the lab. You might have heard of exoskeletons. These are sort of becoming more prevalent now. They've been used quite successfully to actually support staff. They were used to help baggage handlers to prevent back injuries, so they can offer some lumbar support, offer some more physical assistance and strength to actually support people with, say, moving and handling tasks. And then robots, which are very much focused on supporting people to conduct rehabilitation, so post-stroke upper limb rehabilitation, for example, or offer support by coaching and prompting, so reminding people to do their exercises or eat properly on time. So this is a quick walkthrough of all the different types of robots, different categories of robots. And what we are interested in is thinking about where and how these robots are deployed along the patient care continuum. So where we see the greatest need at the present time is for supporting people with quite acute needs who are in hospital and stuck because there's nobody in the home to be able to support them. So being able to use some of these robots to augment human support in the time where people might not be available is something that could really address some of the gaps that we are seeing today with our health and social care provision. But it is no easy task. As you might imagine, we do have a shortage of health and social care professionals all along the patient care continuum, emerging shortages in social care compounded by cuts to resources and funding. And so we want to be able to address preventing people from ending up in hospital. So we want to be able to use these robots to ensure there's some sort of reliable intervention earlier on. And then we also want to make sure we are able to use these robots, which are autonomous systems or can be controlled by a person independently, so that we can actually encourage more self-management of long-term conditions. And we also want to address issues like social isolation, use the technology to enable more help and more connections with people who might not be able to get to the person physically. But it's a complex situation with lots of long-term conditions that people have. This is a tag cloud of just 20 people, service users who were being provided with care at home, working with one of our care providers, partners in London. And a whole range of different long-term conditions occurring together, together with people's changing conditions due to changes in their level of frailty or general well-being, mean that people have a range of different impairments which need to be considered when thinking about how people will interact with these robots. Our focus has been on physically assistive robots, and I'm not going to tell you too much more about these because we're going to go and have a look at the Leo Walker. This is a ceiling-based robot that I had in my previous lab in Bristol that we constructed to be able to support the sit-to-stand transfers and also mobility. And these types of robots offer independence, and where we're looking to work is how much can we make the robot interaction and interface easy to use, so people and people who are supporting them at home are able to manage with these robots. Now, the challenges for safety come from the fact that people will have a range of different conditions that change over time. And it's important to be able to have a system that's able to look at how and what these changes are and how they're taking place and be able to adapt to their changing needs. If you're not doing that, if you're not able to do that, then you start to run into problems where the system is operating at a level which is no longer suitable or fit for the person as their needs have changed. So not only are we looking at the person's own condition, but we're looking at the environment in which the robot might be used. So in the home, out of the home for mobility assistance, lots of clutter. You don't know what's going to happen when we've got vulnerable users in the loops, and of course people's pets and grandchildren. Maybe wanting to go for a ride on the robot, for example, covering up some of the sensors and then resulting in problems. So how do we work and navigate through this whole set of problems which arise from working in the real world itself? So we've been drawing on existing health identification, risk assessment and safety analysis methods, which have been used quite extensively with other types of systems, as well as developing and using new methods. For example, the environmental survey hazard analysis approach developed by my ex-colleague Chris Harper at Bristol Robotics Lab, with the aim of working through methodically through the environment and the interactions that a person and a robot, or people and a robot, will be engaging in to identify various issues. And then other approaches such as the ecological interface design approach, we're always looking to see where we can build on existing methods, but in particular, be able to use these and enhance these methods so they fit with the challenges that we're working with. People's conditions changing, a system needing to adapt autonomously or under direction of an expert user or the person using the system themselves. Because of time, I'm not going to go into detail here, but you can ask me questions. We're looking to see how we take a human factors approach to, first of all, record what happens as people's conditions change over time. And we start off by using simulation suits, aging simulation suits, etc. You can see me wearing one, which is simulating in this picture here, stroke. We've got in our lab, and we'll take you through to see a motion capture system. So here I've got a whole range of reflective markers on an ordinary rollator, and we put these on our robotics walker as well to identify what happens when people move around different kinds of cluttered settings in the home. What happens when they get distracted, when they've got cognitive load, or they're stressed, and there are changes in their gait and their balance due to changing levels of frailty. We use a whole range of sensors to be able to, and you'll see us how we're using thermal imaging, different types of EMG and motion capture systems to try and track and recognize and use machine learning methods to be able to identify how and when people's condition or mobility or movement is changing. We've been doing research where we've been trying to understand with experts as to what could go wrong. If somebody was being supported for physical mobility, for example, what kinds of things could happen as they were using these devices, and be able to understand how we'd recognize these issues, as well as then what we would do in relation to preventing them. So there are things related to the user themselves, user feeling anxious, user getting tired, falling over, having slippery hands, and the robot itself adding to that list of possible potential risks. And we've been drawing on a range of different safety assurance standards, but finding out that even the key one, the 13482, which was developed for safety requirements for personal care robots, aren't providing us with adequate standards and regulations and guidance on using these in the circumstances that we are hoping for them to be used. So there are a number of regulatory issues when you think about physically assisted robots, and I'm sure you're going to be familiar with these. And what I'd like to hear from you as we go around the lab is whether you think these are fit. What else do we need to think about? How can we start to address developing new standards and regulations that help us to address and ensure clinical safety when using these? And it's not just about ensuring clinical safety when using these devices. We also need to be able to understand who does what, when and how in relation to the use of these robots. So as we use these robots, which are connected to smart home sensors in the home, and hopefully the Robin robot will be working when we go through into the lab, you'll see how we are able to leverage off-the-shelf smart home sensors to be able to get the robot to offer support and advice as and when needed. But we have realized that one of the things that we should have been doing from the beginning is thinking about what the future care workforce will need in terms of training needs to be able to support the robot. We've got a situation where we now are getting more engagement with health and social care professionals to understand what are the concerns from various types of perspectives around people using robots in the home or even in care settings, and then thinking about, well, how do we then rethink the design of these robots to ensure that we're addressing these safety related concerns. And so before we can get these technologies out there, there are various issues that have to be addressed in terms of what types of skills are needed to set up and maintain these technologies, how usable are they going to be, issues related to what data is collected, who's responsible for it, who curates it, how long is it kept for, do we need to have an audit trail, how does that impact on people's privacy, etc. So as we work through these questions, interacting with people like yourselves is a vital part of how we're going to progress development in these areas. So the who, does, what, when, and how often questions still remain unanswered. So we don't want to get to a situation where we are held back by deploying these technologies because we haven't been considering these other aspects of their use. We've been looking at a project where we've actually had some telepresence robots in people's homes over a 6-week period as part of supporting them to gain confidence. So somebody comes in who's been trained to offer the person in their home support with doing exercises or just talking to them and to help them get confident and start to engage with their physical rehabilitation. We do this for a period of 6 weeks, and the aim is to give people the confidence to start to then participate in activities outside the home. And it is one of the robots, telepresence robots, that Brett's going to be using later on. I'm not going to show you the video there. We ran some studies, and now we've got a very clear framework on how we deliver this kind of 6-week reablement support, if you like. We've been working with service users within residential care homes and hope to be rolling this out to the community as well. And we've been monitoring benefits both to the client and the volunteers as well who are using these technologies in a way to address some of the gaps within our care workforce. We've encountered from using these systems in real world settings, as you can see here. Again, we've got to work through people's real home environments where there are cat toys and clutters and other kinds of devices, thinking about aspect related to training the person who's using these devices, issues around privacy, how we ensure people are safe when they're being supported remotely with providing physical support, who is around and available to offer support and maintenance, and then this one about artwork and display setup was we're using these in other kinds of therapeutic settings as well, where we're engaging people in art. We've also got big challenges around limitations of our technical infrastructure. We still have large parts of the UK with poor connectivity. We have old buildings with thick walls, which mean that it's difficult to have reliable connections. People don't have adequate power sockets. Actually, there's a big worry now about people wanting these devices in their home because they're worried about their energy costs, etc. We've got limitation to space. In the UK, we have small homes. Quite a few of these robots have been made in other countries where there's more space. So to end, I'm just going to finish with various types of safety considerations. we are working as part of our research on a problem or a set of solutions which are a step change compared to existing ways of delivering care. However, one of the things we haven't done, which I hope this session will get you thinking about, is how these technologies are disruptive and are going to change actual ways in which care and support is delivered and received. So are we prepared in terms of having these systems and working alongside these systems, thinking about how they will be supported, making sure that these systems are able to address clinical, cognitive, and psychological care needs above and beyond just providing that functional support? Because if you don't look at these aspects holistically, it's going to get really difficult to ensure that these systems are actually viable solutions. And last but not least, we need to address the gaps in industry standards and design methods related to how we understand unmet needs and requirements, how we conduct safety analysis and do risk assessments of these new types of devices, which are systems that can adapt themselves, and how we ensure we continually are able to verify and validate their performance on an ongoing basis. And that's where I shall end my presentation. Thank you. So I shall stop sharing my screen.
Thank you, Praminda. Okay, just to let everybody know that we're just about to switch over. So I'm going to take control of one of the robots. Hopefully technology will not fail me. And I will say now that it's the first time, sorry, this is the second time. So I have driven the robot once before. So if I crash, please, you know, it is being recorded. There will be witnesses. But yeah, just for a second, it will be a bit silent just as I switch over to the robot. And then Praminda will resume her presentation as we talk through that. So if you just give me a second to switch over.
Did you do share sound? Okay. Can you hear me? But can the audio? Yeah. If somebody could unmute their microphones. Oh, okay. Great. Okay. So I'm just going to close my laptop. So I'm just paying attention to you now. Yeah. So everybody online, welcome to the Cobot Makerspace here at the University of Nottingham. If you'd like to come through, Brett, so if you move forward, that's it, and follow me around. So you can see here, you're in this lovely space, which is our Cobot Makerspace. Just come through. And you can see some of our robots in this space. We have, we're working on a number of applications. Remember I talked about teleoperation earlier on. So we're working to see how we can remotely operate these robots to offer assistance to people. These robot arms are being used to help people with tasks such as pick up objects. We're trying to use feedback, so a remote operator gets feedback on the when they grip something, how it feels to grip it, so they know how much force to exert. And that information then can be used to train the robot arms to do this automatically. So these sort of tasks are useful for remote help, and some of the projects that are going on with my colleagues, we're working with nuclear decommissioning where a human can't go into the environment, and then these robot arms can be used in a pair where the operator from one end outside of the dangerous space will control the robot, and the robot's motion will be mimicked and picked up and performed by another robot in that dangerous place. We've got a number of different arms. So this is our room. You can see different types of arms. We've got a system called Hapkion, which provides a good level of force feedback when we use it to operate and control things remotely. You can see some of my students here have been trying to get the robot arm to pick up this window cleaner bottle, which is empty. And one of the things that's interesting, obviously, is the amount of force that needs to be exerted will depend on the texture or the weight of something. And then the robot also needs to determine this through some sort of sensors, according to how heavy the object is, whether it can actually pick that up. So is it powerful enough to pick it up, or will it break or damage the robot? So you can see from a safety perspective, there's a lot of other information that needs to be known about the context of what the robot is doing and what it's picking up and operating with. So if we go out to some of the other spaces here in our lab, just follow me through. You're doing a great job of driving. I hope the online viewers are impressed by your driving skills. Yeah. Just hold on a second there, Brett. Let's see. Oh yeah, there's a bell there to take it up you on your way. So I'm going to take you through here. So if you just like to go through the door. This robot that Brett is driving, people at home can hear me, can they? As I can hear you very good. Okay, very good. So yeah, if you turn around this way, you know your way around now. So we've got a series of rooms down here where we're trying to create realistic environments. Oh, that's okay. Realistic environments to conduct our experiments. And what's happened to the lights in here? Oh, you've do you want to come turn around? Turn around. You missed it completely. Okay. Do you want to go on? Okay, yeah. So actually, while you're here, you can see, Brett, if you look at the robot here, then people at home can see what this robot looks like, the one you're driving. So you can see it's got is like a Segway, so it's it balances. So I can move it and it will not tip over. We actually don't use this one with the self-balancing one in the home. We use it one which has a wheelbase because of safety-related concerns. This could tip over if the force was too high or if it bumped into something. It does have obstacle avoidance, but we prefer a wheeled base. And then, like Brett, you can see on the screen, control it for moving around. I'm just going to put it into parking mode. You can make it go up and down as well. Brett, do you want to show them how it goes up and down, your one? So it's in the top left of your screen. You can see a little icon of the two. Yep. So when you're driving, it's best to keep to the lowest heights to ensure. While you're up there, you can just do a little turn around and have a look. You might be able to zoom in to the cameras in here. So we've got an 8-camera Vicon system. I showed you one of the pictures where I had those reflective markers on myself, and that's what we can use to pick up gait and mobility. So if you just come this way, Brett, yeah, and people can see those other cameras. You might want to come down a bit just so you're more stable when you move. The smart home sensors on the screen. So, yeah. There we go. So if you come this way, say hello to Robin. There you go. Hi, Robin. So Robin there is a socially assistive robot, and if you turn around, Robin's connected to some smart home sensors. So if you just come this way, actually what we're going to wait, where, yeah, position yourself down here, so you can see what I'm doing, and then you turn around and see what Robin does. So you can see these contact sensors on the window. Oh, actually, just turn around and to the window. There we go. So wireless contact sensors. Now if we want to be able to zoom in, you can see where I'm pointing. Yeah. Are you able to? Yeah. Okay. I'm just going to open that, and then when I open it, turn around, look at Robin.
There is a lovely breeze coming in through the window.
So with the window open, and if you turn right around, you'll see our smart home, the rest of the sensors on the smart home hub. And when I close the window, you'll see the window be there, which is showing open at the moment. You can come down if you want to see the screen more clearly. Okay, and I'm going to close that. You'll see it close.
That is nice and warm now.
And so that information is being picked up also by the socially assistive robot, Robin, in our case, to be able to offer support and advice. So using machine learning, we could learn people's patterns of behavior, and then we can do things like task prompting. So if they forget to do something in a sequence of events like making a cup of tea, they leave the fridge door open, etc., then the robot is there to support them with giving them prompts and interact. And we've been doing a really exciting demo, which isn't actually working at the moment because the student's not here to show you, but we've linked it up to ChatGPT, and that's proving to be really exciting because you can now start to have a more socially interactive conversation as well with something like that. So if we go into the other room, I want to leave some time so people want to ask questions. If there are any questions, maybe you can see in the chat. Are there any questions people want to ask? Okay. Well, people can always unmute their microphones and ask questions. I should be able to hear them because you're sharing sound. Okay. Yeah, let's go to the next room and we'll see some of the other robots. So this is our living lab space, and we can make it as cluttered and messed up as we want. Oh, no, not that way. Turn around a bit. Yeah, perfect. So you can see here, if you were, Brett, if you were supporting me in the home, rather than having to sit in a traffic jam, you could be here 4 or 5 times a day, helping me, making sure I was eating properly, talking me through steps and instructions of what to do. accompanying me around the house to make sure everything was okay. And I don't have to do a thing. So you connected to robots. I don't have to know how to use a computer. The whole system just works with you in control. So this is a really powerful technology to be able to augment the support and care people can provide. So we're just going to go into our simulated hospital ward room here. We'll do this one first, and then do you want to come in? And we've got my PhD student Zilling. Zilling, say hello to. There's an audience there from the National Safety Association. There's Zilling. And if you come and stand about here, Brett, and then look back at that screen, you'll be able to see we're using thermal imaging, and you can see me sitting on the bed there. You can see me lying down on the bed, and you can see if I have a fall and I end up on the floor. This is actually, so if you turn around and look, I'm actually on the floor now. Two thermal imaging cameras in the room provide quite a lot of detail, which is also privacy preserving, to be able to set up automated alerts to people who might need help. So we've got one thermal imaging camera there, which is more long range, and a short range one on the other side there. And we're doing automated image analysis to be able to recognize people's state, even when they've got their legs up in the bed, getting ready to get off the bed, etc. So something that would have less false positives, fewer false alarms, to be able to support somebody with monitoring. And then if you turn around here, we'll switch the screen onto the walker. So here we have a robotic walker. Now this walker has got 70 different sensors, and it can support me to navigate and walk around. So I don't know if you just want to move a bit further back so you get a good view of the walker, but if you turn around and have a look at the screen, Brett, there, you'll be able to see, this is data from the handlebars. And if I'm leaning more on one side as I walk, you'll be able to see how the data from the handlebars can be used and recorded. So if I'm starting to get more frail over time, or if my balance is changing, this kind of data can be used to provide information. So you can see me leaning more on one side, leaning more on the other, and again, using machine learning methods, we collect this data for over long periods of time, which we can use. So we can use a robotic walker such as this. You should be able to hear it talking to me. Yeah, so it's just telling me to move ahead. If you can hear a little clicking beat sound, that's to support people with Parkinson's who might get freezing episodes, so that little beat and rhythm helps with that. We're also instrumenting ordinary relators with sensors, and you can see this one with a strain gauge fitted to it, so we can get similar data. If you want to move back a bit, you might be able to see that more clearly. I can't see what you're looking at there. And yeah, so we've got some electronics kit just that we can instrument into ordinary relators and be able to pick up this long-term data that we are analyzing to see what's getting changed, and then use that to offer preemptive support to people. So this is some of the research and our equipment that we're using here in our lab. So thank you, Celine, for setting all of that up for us. And if we go back into the main Cobot makerspace, I'll jump in on Teams to answer questions. Thank you. Here we go. So yeah, straight down the corridor there. Should be able to, yeah, that's perfect. Okay. And actually, it might be quicker if you just go into the living room. I'll go and grab my laptop. So just go into the living room. Okay, so I brought my laptop in here. We can just sit here. Okay.
Okay. Not sure if anybody can see me or not.
Can't see you, but can hear you, Brett.
Oh, good. Technology has failed me, but not quite the technology I thought it was. Hang on a second. Let me reset my video. Ah, there you go. I believe I'm back.
Yes, you are.
And hopefully Praminda is there somewhere. No, it seems that we may have we lost Praminda very briefly. She's just coming back in.
Sorry, that took a bit longer to come back in.
That's okay. They lost me as well. So apologies to all for that very short technical glitch. Excellent. That's good. Okay, so yeah. So thank you, Praminda. And yes, we've got a couple of questions. I've got a couple of questions. But certainly from Jackie has asked how do they manage different floor surfaces?
Yeah, that is one of the challenges. Quite a few of these are quite heavy. And so if they are different thresholds, etc., they are able to move over. They've got motors that will carry them over. We'll work on carpets, very thick pile carpets. You could run into problems. Where we do have issues is around edges of rugs, edges of thick rugs. So in something like this, if you look down there, you can get over it, but if it's too thick, there could be an issue. So yes, these are some practical issues. Now I didn't show you, we've got one of those Boston Dynamic dogs, the hexapods, the quadrupeds, which can actually move over things. So that makes it easier. They've been designed to be able to operate on uneven terrains. So it depends on where the robot's going to be used, and given that, we can decide what's the best form factor that it needs to have to be able to cope with different terrains.
Thank you. And we've got time for one more question. I've got it's worded here. Of the 4 areas identified at the outset of the presentation, is there any which are closer to use in a real situation?
Yeah, so the one related to social assistance with robots such as the Robin robot and the telepresence. So the Robin robot there, which can move around. One of the issues around systems like that, obviously, are costs at the present time. But the telepresence robots we already have on trial. And actually, I also, during COVID, realized that there was a gap in terms of providing support and ongoing maintenance and training for the use of these robots. So I've actually set up a not-for-profit company called Robotics for Good, and we actually make these available. And we've got a special offer on at the moment if somebody wants to try it. I'm just going to post the link in the chat. And this is a system that's already available to use. So we supply to platforms which have been certified for commercial use.
Excellent, thank you. Unfortunately, we have run out of time for questions. However, I do have a list of questions that I will be sending Praminda. And then, as I say, we will send out a Q&A sheet for all that attended, which will be posted on the website. Obviously, the recording will also be there, and the presentation will be available. Praminda, fascinating as ever. That's the second time I've used it, and I have to say it's brilliant. And as I'm sure everybody can appreciate, there's lots of development around the technologies and other bits and pieces, and around the questions. So yeah, but I mean, certainly it's strange to sit here and watch a presentation about robots being in the home, you know, enabling a safer environment and enabling people to kind of, I suppose, dial in with their loved ones and in a professional capacity as well, to assist people. So yeah, absolutely fantastic. It was really, really interesting. Thank you.